Good day, everyone. I'm Decadent Inclinar John Lloyd, and we're going to tackle about gyro compasses, errors, and limitations. After this report, we should be able to describe the errors and limitations of a gyro compass, determine the cost and adjustment to be made for the different errors of the gyro compass. What is gyro compass? Do you know what is gyro compass? Gyro compass is a non-magnetic compass in which the direction of the true north is maintained by a continuously driven gyroscope whose axis is parallel to the Earth's axis of rotation. What is errors and limitations of a gyro compass? Gyro compass has errors. The errors to which a gyro compass is subjected are speed error, latitude error, ballistic deflection error, ballistic damping error, quadrantal error, and gimbaling error. Additional errors may be introduced via malfunction or incorrect alignment with the center line of the vessel. Limitations of a gyro compass. It has It requires a constant source of electrical power in the event of any interruption in its operation for any length of time. Nearly 4 hours may be required for it to be settled back in reliable operation. Number two, it requires intelligent care, attention, and maintenance. Number three, the accuracy decreases at latitude above 75 degrees.
Hello, I am Tech Cadet Awabanlije discussing the cost and adjustment to be made for latitude error and speed error. Latitude or damping error. This error is present in a compass that is damped by tilt. A compass damped and tilt always settle east of the meridian and above the horizon in the new hemisphere and vice versa. Its magnitude is determined by the latitude of the observer, sign as error, tangent as latitude. At, at the equator, the error is nil. In all northern latitude, the error is eastward and vice versa. A gyro compass is provided to a latitude rider or adjuster for the purpose of damping error, which shift the lubber line in the appropriate direction equal to the amount of error. And the cause of latitude error is when a compass that is damped in tilt that has this error. In northern New Hemisphere, a compass that has been damped in tilt will always settle above the horizon and east of the meridian. And to adjust the latitude error, a latitude adjuster is given a gyro compass for the purpose of damping error, which shift the lubber line in the appropriate direction equal to the amount of error. Next, please. Speed error. The direction in which the compass settles is therefore different from the direction of the true north and depends on the ship's course, speed, and latitude of the observer. This error also increases as the observer's latitude increases. The error is westward on all northerly courses and vice versa. To compensate for streaming error, a speed rider is provided which, in association with a latitude rider, shift the lubber line equal to the streaming error in the appropriate direction. Speed error. The cause of the speed error is when the compass final reading deviates from the true north because it is influenced by the ship's course, speed, and observer's latitude. As the observer's latitude rises, so does this inaccuracy. On northerly trajectories, the mistake is westward and vice versa. And to adjust the speed error, the lubber line is shifted in the right direction by the speed rider working in the conjunction with the latitude rider to adjust the streaming inaccuracy. Thank you. Next.
Hello, I am Deck Cadet Malagar Selfred. Continue discuss the cause and adjustment to be made for gimbaling error and ballistic deflation error. Gimbaling error. This is due to the tilt of the compass rose. Directions are measured in the horizontal plane. When the compass card is tilted, the outer rim's projection in the horizontal is an ellipse, and the graduation are not evenly spaced for, for normal tilt angles. This error is small and can be neglected. To minimize this error, the outer ring of the gimbal of each repeater should be installed in alignment with the fore and aft of the bezel. Of course, the lubber's line must be exactly centered as well. So the cause of gimbaling error by taking readings from the compass card when it's tilted from the horizontal plane. The adjustment of gimbaling error is to minimize this error. The outer ring of the gimbal of each repeater should be installed in alignment with the fore and aft line of the bezel. Next, ballistic deflection error. A temporarily oscillatory error of the gyro compass is introduced when the north-south component of the speed changes as a result of speed of or course. Change an accelerating force acts upon the compass, causing a surge of mercury from one part of the system to another in the case of the non-pendulous compass or a depression of a mass in the case of pendulous compass. This aspect of design involves slightly offsetting the ballistic according to the operating latitude, upon which the correction is dependent. As latitude changes, the error becomes apparent but can be minimized by adjusting the offset. When the north and south component of the speed changes to due speed or course, the gyro compass experiences a brief oscillating inaccuracy. Change when an accelerating force applies on the compass. It deflects a mass in the case of a pendulous compass or causes a surge mercury to move from one area of the system. Next.
Now let's bound to the fifth cause and adjustment to be made for the different errors of the gyro compass. I am Decadet Matuog Lavignati. The fifth one is quadrantal error. The first occurs if the center of gravity of the gyro is not exactly centered in the phantom. This causes the gyro to tend to swing along its heavy axis as the vessel rolls in the sea. It is minimized by adding width so that the mass is the same in all directions from the center. Without a long axis of width, there is no tendency to swing in one particular direction. This error is corrected by the use of a second gyroscope called a floating ballistic, which stabilizes the mercury ballistic as the vessel rolls, eliminating the error. Another method to use two gyros for the directive element which tend to process in opposite directions, neutralizing the error. A quadrantal error is caused by an NDB signal. NDB means a non-directional beacon, and it is a radio beacon operating in the MF or LF band range. Okay, let's back to the topic. Quadrantal error is caused by an NDB signal bending towards the magnetic axis of the aircraft, causing the signal to appear to come from an incorrect direction. Next, please. Lastly, ballistic damping error. Ballistic damping error is a temporary oscillation introduced by changes in course or speed. During a change in course or speed, the mercury in the ballistic is subjected to centrifugal and acceleration deceleration forces. This causes a torquing of the spin axis as a subsequent error in the compass reading. This error is counteracted by changing the position of the ballistic so that the true vertical axis is centered. Thus, not subject to error but only when certain rates of turn or acceleration are exceeded. So that's all for our topic 9, which is entitled Gyro Compass. Thank you so much, sir. God bless and stay safe.